So our next problem is a very interesting problem and a very conceptual problem at the same time. We have a coin which is tossed n number of times and we need to find the probability that head is present at odd number of times in these n tosses. Now the best way to solve this problem is by just analysis. We know that in a coin toss the probability of head is equal to the probability of tail, which is half. There is no biasness between a head coming in a toss or a tail coming in a toss. So in these n tosses also there will be no biasness between a head and a tail. So the probability of a head coming at an odd number of times will be half only, because there is no biasness between a head or a tail coming. Hence the probability of this head coming at an odd number of times is again half. This we can also do by using mathematics. We need head coming odd number of times. So let us say case 1, it is coming one time, so it is NC1 plus NC3 odd number of times, one time, 3 time, plus NC5 upon the total number of ways in which a head or a tail, in which a head can come, it is NC0 0 times plus NC1 plus NC2 plus NC3 up till NCn. We know that this is equal to 2 power n upon 2, because the total number of even ways plus total number of odd ways are equal and they sum up to get 2 power n, and this is equal to 2 power n. So this is equal to half. This is the way in which, this is the mathematical way in which we proved that the total number of ways in which a head can come in and tosses odd number of times is half. Or what we can do is, we can assume the probability of a head coming to be equal to P and a probability of tail coming to be equal to Q. Now we apply binomial theorem. P plus Q power n is equal to P power n plus NC1 P power n minus 1 Q power 1 plus NC2 P power n minus 2 Q power 2 up till Q power n. Now what we require is the sum of the even terms in the expansion of P plus Q power n, because the second term contains the term NC1, the fourth term contains the factor of NC3, and as we saw in the earlier formula, we required the sum of NC1 plus NC3 plus NC5 only because we want head to come odd number of times. Hence our required sum is NC1 P power n minus 1 Q power 1 plus NC3 P power n minus 3 Q power 3, and this summation is our required sum. So this is equal to, this P power n minus 1 is half power n minus 1 into half is again half power n. This is half power n minus 3 into half power 3, which is half power n, because P is equal to Q is equal to half, because the probability of coming of a head coming is equal to probability of tail coming, and both are equal to half. Similarly, the next term NC5 into P power n minus 5 Q power 5 will be, this will be half power n minus 5 into half power 5, that is half power n. So half power n can be taken out common, and this comes out to be equal to NC1 plus NC3 plus NC5, and this we know is equal to 2 power n minus 1 divided by 2 power n is half again. Hence in order to solve this problem, the first method we used was the analytical method. We just analyzed that there is no biasness between a head or a tail coming in a toss, hence the probability is half. In the second method, we just wrote the total number of favorable cases divided by the total number of cases and got the probability is half. And in the third method, we used the binomial method and got the required probability to be the sum of all the even terms, and hence our final answer is half, which is the probability of head coming at an odd number of times.